Okay, let's get started. Well, in order for us to be able to simplify some more sophisticated radicals, we're going to need a couple of basic tricks. And the first trick is understanding that whenever we take a radical divided by the same exact radical, that's equal to 1. All right, so look at all these things that equal 1. Again, by taking a radical and dividing it by the same exact radical, we're getting 1 in here. And so please keep that in mind. Anytime we take a radical and divide it by the same exact radical, we're going to get 1. And this is going to come in handy because if I have a number and I times it by 1, secretly we're not really changing the number. All right, so it may not make sense of why we're using that just yet, but keep in mind a radical divided by the same exact radical will equal the value of 1. At the same time, we're going to be using this concept as well. If I take the radical and times it by the same exact radical, I don't get 1, but notice the radicals go away. This is true for any number. If I have radical 8 divided by radical 8, I'm going to get 8. Radical a divided by times radical a is going to give me a. If I have radical 5 times radical 5, it's going to give me 5. So all these are true in here. Whenever we take a radical and multiply it by the same exact radical, the radical disappears. And if you're kind of curious why, if I take this one right here, like radical 5 for example, and times it by radical 5, if I did mesh these together, that would be the square root of 25. And guess what? The square root of 25 is 5. And so it's true that if you take a radical times the same exact radical, the radicals disappear. Well, keep this trick in mind as well as we do the next batch of problems. And the next batch of problems is right here. So let's do our first example. Well, the first one is radical 1 all over radical 6. Well, radical 1 is just 1, and radical 6, here's our problem. We have a radical in the bottom, and we have to get rid of it. And so we're about to play a trick on it. We're about to play the trick of we're going to multiply by 1. Notice when you multiply something by 1, it is not going to change its core value. So this doesn't look like a 1 here, but whenever we have a radical divided by the same exact radical, that's the value of 1. And why would we do such an evil thing and start multiplying stuff by radicals? Is because when we multiply straight across now, that becomes radical 6, and this is the beautiful part. Radical 6 times radical 6 is 6. And then we are done. The radical just went from being on the bottom to now it's being moved upstairs. Being upstairs is not a problem. That is our first example there. Let's take a look at the next one. The next one says radical 3 divided by radical 7. Well, in this case, 3 and 7, they don't simplify with one another. 3 doesn't go into 7, 7 doesn't go into 3, so we need a trick. Well, the radical 3 is not bothering us. It's the radical 7 that should be bothering us. That's the radical that's in the bottom. So we're going to play a trick on it. We're going to multiply the top and the bottom, to be fair, by radical 7. And essentially, this value right here is 1. So we're not really changing the core value when we're multiplying by 1. So when I multiply straight across, that's radical 21, and radical 7 times radical 7 is just 7. And that's it. Don't try simplifying this. Don't go, oh yeah, that's radical 3. No, 7 is not in a radical sign, and 21 is in a radical sign. So they don't mix. If I did have radical 21 divided by radical 7, that would be radical 3. But that's not the case here. So this one is done just like it is, and the radicals are no longer on the bottom. Let's try a few more. Let's try 37. This is radical 5 divided by radical 12. Well, 5 and 12 can't be simplified right now, so I have to play a trick on it. So I'm going to multiply it by 1. Radical 12 divided by radical 12. When I multiply straight across, that's radical 60. Be careful of that one. And this is going to be a 12 on the bottom. Well, it looks like we're kind of done. The radicals are no longer on the bottom, but go back a few sections. That should bother you right there. Ask yourself, does 60 radical 60 cannot be simplified. Well, it can be. That turns into 2 radical 15 all divided by 12. And if I went a little too fast for you, what I just did was I said 4 times 15, that equals 60. And the radical 4 became a 2, and the radical 15 stays a radical 15. But we're still not done, because now look what can happen in here. The 2 and the 12, since they're both numbers, they're not under radicals, they can be simplified too. So this final answer is radical 15 all over 6. So hopefully you can see the intensity of these radicals and how we simplify them is getting a little tough. Let's try a few more in here. Let's do 38. 38 says what? Well, it's radical 7 divided by radical 18. I'm actually going to do this 2 ways. Well, the first way is the way we've been showing you so far. Well, that's radical 18 times radical 18. Excuse me, divided by radical 18. Because I'm trying to get rid of the radical 18s. I noticed that 7 and radical 18, they can't cancel with one another. So when I take 7 times 18, that's radical 126, all divided by 18. Now I have to ask myself, can 126 be simplified? And so is there any factors of 126 that are perfect squares? And the answer is yes. And notice it's 9 times 14. 9 times 14 is 126 all over 18. And we're still not done. Why? Because radical 9 is a perfect square. That's 3 radical 14 all over 18. And we're still not done, because 3 and 18 could be simplified. 3 goes into 18 6 times. So it's radical 14 all over 6. Well, that was the first way I wanted to show you. And you might like an alternative technique to do this if we do a little simplification right from the very beginning. Notice 7 and 18 don't go into each other, and radical 7 can't be simplified by itself, but notice radical 18 can be simplified into what? That is going to be 9 times 2, so that's 3 radical 2. So all I did right now was take radical 18 and just break it into smaller pieces here. 3 times radical 2. So now radical 2 and radical 7, they don't simplify, so we still have to get rid of the radical 2 because it's on the bottom. So instead of multiplying by this big number, radical 18 times radical 18, we're going to be multiplying the top and bottom by radical 2. And what do we get? Well, we get radical 14 upstairs. And on the bottom here, think about it. This is going to be 3 times 2, because radical 2 times radical 2 is 2. So it's radical 14 all over 6, and we got our answer. What I just did, and that was the second way how to do this, is instead of multiplying by these large numbers, getting you larger and larger numbers that are a little more tough to negotiate and get smaller and to simplify them, I notice I can simplify 18 right away. Either one of these techniques work. You have to be very comfortable with your times tables and know what to do in any case. All right, let's try 2 more and take a little break in here. Well, the next one is radical 12 divided by radical 5. Well, 5 and 12 don't mesh with one another, but I can see, just like the previous trick, radical 12 can be simplified. Radical 12 is 2 radical 3 all over radical 5. So I just took this radical 12 and I just made the number smaller, just like in the previous example. I just made it smaller to begin with to kind of make my life a little easier as I start moving around some of these radicals. Well, 3 and 5 don't simplify with one another, but so I have to get rid of the radical 5. So this turns into what? This turns into 2 radical 15 all over 5. And that's going to be my final answer. Why is that? Because I noticed 2 and 5, they don't simplify. Warning, don't start thinking the radical 15 can be simplified with the 5. One's a radical, one's not. That's not allowed. And we got one more to show you. Let's do number 40. So this is going to be radical 5 all over radical x. Oh, x is not a number here. It's a variable. But we have the same exact trick. What are we going to do? We're going to multiply the top and the bottom by radical x, and that's the value of 1. So the numerator is going to be radical 5x all over x, and now we're done. Notice these x's don't cancel. Why not? One has a radical, the other one doesn't have a radical. You can't cancel these. It's only when they have the same exact, it's either they both don't have a radical, that would be 1, or if it's radical x over radical x, that would be 1. So in this case, the goal was to simplify this, and the problem here was the radical is in the bottom. So notice the final answer, we don't have a radical in the bottom. All right?